previous test an extra set of practice questions online. It's called the practice test online on Polaris, and then the solutions are posted there as well. So this gives you at least one example of everything that you're going to see. On day one, Friday, you're going to see 9 problems, the first 9 that are on here, and we'll get through as much of it as we can today. And then day 2, there's only going to be 3 problems, but all 3 of those problems are going to be full hypothesis tests from start to finish. So those are a little bit longer, where you have to write the hypothesis and draw the sketch and do the z-score or t-test and make a decision whether to reject and not reject that whole thing. So 10 to 12 is day 2. It says, I think it says it on your paper there at the very first slide, right above the first problem. Yep. So 1 through 9, day 1, Friday. 10 through 12, day 2, Monday. Okay, and then bonus is due on Monday too, if you want a little extra practice on that. Okay, good. Basic calculator on both. Great. Okay, let's get started. See if we can get through here. Okay, so first problem, we have a random variable x. It's normally distributed. We are given the mean and the standard deviation. We need to find the following and shade the area on the standard normal curve. So this is going back to chapter 5 is where we're starting with all this stuff, where we started with our z-scores. Okay, so you're going to need your z-score formula for this. To transform a value into a z-score, we do x minus the mean, divide by the standard deviation, and that is on your sheet somewhere, I think. It's on the very top. This is chapter 5. Okay, so the x value that we're given for A is 36 minus our mean, 37, divide by the standard deviation, 3, and you're going to want a decimal for this because that's what we have on our z chart. So 36 minus 37 is going to give me negative 1 over 3 is negative 1/3, or negative 0.33. If I give it 2 decimal places is my z-score. Okay. Here it is a probability of x being less than 36. So that means we are looking to the left of this z value. So you can go ahead and sketch that if you want. Negative 0.33 is going to be pretty close to the mean. So something like that. Okay. And then we're going to find that value on our z-score chart to find the appropriate area that we're looking for here. All right, so yours is pink for your z-score chart. Negative 0.33. You should see 0.3707. Is the area to the left of that z-score. Everybody find that okay? Okay, so next couple problems are just extra practice with that then. All right, so the next one, we have an x value greater than 31. Okay, so again, I'm going to take my 31, I'm going to transform it into a z-score. 31 minus 37 over 3, that's negative 6 over 3, so this one's exact, negative 2.00. Okay. Negative 2.00, so negative 2 is going to be down on the left a little bit, but this time we want an area greater than that, so we're going to shade to the right. Okay. So now we're going to find that value on our z-score chart, which is 0.0228. And do you guys remember what I do with that if it's area to the right? Because right now I have area to the left. We do 1 minus. We do the complement of that. And I get 0.9772. So you can kind of make sure what you're shading is reasonable. Remember, the total area under the curve is 1. I shaded quite a bit of it, so I should expect the number pretty close to 1. Okay. Last one, we have a probability between 2 x values. All right, so we need to transform both x values here into z-scores. 34 minus 37 over 3. which will give me -3 over 3. Again, this one's nice and pretty. -1.00. And then the same thing with 38. 38 minus 37 over 3. That's going to give me a positive 1/3, or positive 0.33. Okay. So I can sketch both of those. Positive 0.33 is just going to be slightly to the right of my mean. -1 to the left of my mean, maybe like over there somewhere. So that's the area that we're searching for. Okay, so now on your chart, you're going to find both z values, the areas that go along with them. Okay, so -1.00 gives me 0.1587. And then what was my other one? 0.33 is on the positive side. 0.6293. And then do you remember what we do with both of those if it's area between? Subtract bigger minus smaller. Yep, and that'll give you the area between them, the difference. Okay, so we're going to do 0.6293 minus 0.1587. Grand total 0.4706. Just the shaded area. And the probability that our x value will be between those numbers. Okay? Questions on any of that in number 1? Getting a z-score, finding the corresponding area. All right, moving on. All right, number 2, in a recent year, the MCAT total scores were normally distributed with a mean of 500 and a standard deviation of 10.6. Find the probability that a randomly selected student scores less than a 489. So this is really similar to what we just did. This is just kind of in word problem format, okay? So we're finding the probability that our student's score, x in this case, is less than 489. Okay, so again, we're going to transform it to a z-score, and then we're going to find the corresponding area, which is going to give us that probability. So z-score formula again, x, 489, minus my mean in this problem is 500 over the standard deviation, 10.6. 489 minus 500 over 10.6. I get -1.04 if we round to 2 decimal places. Okay, so now find the corresponding area on your chart. -1.04 gives you 0.1492. And again, it was less than. If it helps to make the sketch like we did in the previous problem, you can. That's area to the left. So that's our probability. You can leave it as a decimal is fine. If you want to write a percentage, 14.92%, that's okay too. Okay. Find the probability that a randomly selected student scored more than a 514. Okay. So again, transform it to a z-score. Subtract the mean, divide by the standard deviation. And I get 1.32. Find it on my chart. .9066. Is that my final answer? Yep, it's area to the right in this case because it's greater than. So we're going to do 1 minus that. And you're going to get 0.0934. Okay. Part C, are either of those probabilities unusual? No? Why? Yeah, both the probabilities, write it down words, are greater than 0.05. Anything less than 5%, 0.05 is considered unusual. Okay. Questions on number 2? Okay, number 3. In a survey of women in the U.S. ages 20 to 29, the mean height was 64.2 inches with a standard deviation of 2.9 inches. What height represents the 95th percentile? Okay, so this one's working backwards a little bit. Bless you. Okay, so 95th percentile means we have an area of 0.95. So we're going to work backwards and find the z-score that goes along with that. And then the formula that we're going to be using for this one, it's actually written in there because it didn't print well when I did it originally. It says on your gold sheet, transforming a z-score into an x value. Okay, so here we're going to know the z-score from this area that we're searching for on our chart. We're going to transform it to an x value, which is going to represent a height in inches for women in this case. All right, so I'm going to put that formula up here, my x value. First, mean plus z times standard deviation. Okay, so we need to find the z-score associated with this area. Okay, 95th percentile means 95% of the data is below this number, which is exactly what our chart gives us, area to the left. So you're going to hunt in the middle for the closest you can get to a 0.95. So let's see how close we can get. Okay, so I can get, it's actually going to be between two numbers exactly. I've got a 0.9495 and a 0.9505. So both of those are the same distance away from 0.95. So what do we do? Add them together and divide by 2, essentially finding the midpoint. So it's the midpoint of 1.64 and 1.65, which if you add those up and divide by 2, it's 1.645 is the midpoint of those numbers. Okay. If it's not exactly between 2, you just pick the one that's closest. All right, so now using my formula to find the x value or the height that corresponds to this percentile, we're going to do our mean that we were given, what was that, 64.2, plus our z-score, 1.645, times the standard deviation that we were given, 2.9. Type it in your calculator. And we're going to get 68.97 inches. Okay. All right. What height represents the third quartile? If you're in the third quartile, what percent of the data is below you? 75%. So we need to know that. First quartile would be what? 25. Okay. So hunt in here for 75%, as close as we can get to 0.75. All right, let's see. I've got a 0.7486 and a 0.7517. Which one's closest? One of those is closer. Yeah, the one that's 0.67. The 0.7486 area is only 14 thousandths away. All right, so 0.67, that z-score is the closest we can get to that 0.75. Plug it in. 64.2 plus 0.67 times 2.9. All right, and we get 66 point, this one's exact, 143 inches. Okay. What is the maximum height that you could have to put a woman in the bottom 10%? Okay, so bottom 10%, be careful here, means my area has to be less than 10%, okay? And sometimes we saw problems that said top, so it meant the area had to be greater than a certain percentage. So here we're going to hunt for 0.10, but we're not looking for the one that's closest. It's got to be the one that's right below 0.10 because we want the area below that number, okay? So 0.10, I've got the closest I can get to it, but less than that is a z-score of negative 2.33. All right, and then use it. 64.2 plus negative 2.33 times 2.9. 57.443 inches. Questions on 3? Oh, did I look at the wrong number? Yes, I did. Gosh. I said it, I wrote it, and I looked at the wrong number on paper. All right, let's fix that. Sorry. 0.1, not 0.01. All right, how about a negative 1.29? Does that sound better? Okay. You guys got to tell me when I do silly stuff like that. Negative 1.29. There we go. All right, let's fix it. $60.459. Here we go. Okay. All right. Any questions there? Okay. Number 4. You wish to estimate with 95% confidence the population mean of U.S. adults who eat fast food 4 to 6 times per week. Your estimate must be accurate within 3 units of the population mean. Assume the population is normally distributed. Find the minimum sample size needed. Okay, so on our formula chart, minimum sample size was in what chapter? That was in chapter 6. So you're looking for the following formula. N equals our z-score times our standard deviation divided by the margin of error squared will give us the minimum sample size needed. Remember, when we use this formula, we will always round up from whatever we get to the nearest integer. All right, so we've got to kind of hunt down some of this information. So we have a 95% confidence interval. So you're going to be looking at your z-score chart. You're going to be looking at your level of confidence. So on these pink ones, it's listed at the bottom. Level of confidence, 95%, 0.95. My z value is a 1.96. Okay. Standard deviation, were we given a standard deviation here? No, okay, we're going to need one of those. Were we given a margin of error? 3. All right, let's make up a standard deviation. Apparently we don't have enough information here. Let's say the standard deviation is, we'll just say like 2.5. Okay, so we'll put 2.5 there. All right, type it in. 1.96 times 2.5 divided by 3 and square it. So I get about 2.67. So what is the minimum sample size needed? 3. Just round up to the next integer. Okay. Go to number 4. Okay. Number 5, a school reports a confidence interval of the following when estimating the mean of student drivers for the population of the student body. Use that confidence interval to find the sample mean and the margin of error. Okay, so remember when we have a confidence interval, we can think of this like a number line. And you have your two ends, 433.8, 572.4. Where is the mean located with respect to these numbers? In the middle is our x bar. And then your margin of error is just, you can see it twice in this picture, the difference between the end of one of your confidence intervals, either the min or the max there, and the mean in the middle. Okay, so to get the mean, we add them up, divide by 2. Find the average, find the midpoint. And that gives me 503.1. To find the margin of error, you're going to find the difference in 503.1 and either end of the confidence interval. So I'm going to do the maximum number there, the 572.4, and just subtract the 503.1. You get 69.3. It's the margin of error. Okay. Questions on 5? Okay, I think we'll try to do one more. That way we can get through at least